Thank you for the invite to present my work. So today I will talk about strike slip tectonics that we see along the Dead Sea Transform. We do spend a lot of time in the field, and today I will share some of the insights that we were able to take from the field, and that we were able to compare it with analog models. Okay, so the outline is I will show you a little bit about the Dead Sea Transform to put you in a picture where we are, what's going on. Then I will focus on the mapping techniques that we use, and then I will present the two models explaining what happened earlier at the breakup stage along these strike slip plate boundary, and then what is happening now. And I will conclude hopefully everything together to make everything more easy to understand. So the Dead Sea Transform is the plate boundary between the Sinai and Arabia. As you can see from these GPS vectors, there is some sort of like a rotation of Arabia, so you have more convergent movement towards the plate boundary, which is here, while in the south is, let's say, more pure strike slip. If you look at the DEM, you already see that there is lots of changes in the morphology. If you start from the south, next to the Red Sea, you have a wide structure that narrows to this transitional zone. Then it is wide again and narrows to the north. You have a beautiful example of restraining band in the Lebanon, and then further north, the northern Dead Sea is very peculiar because it's okay. We have this small depression over here, but then the right side is uplifted while the left side is downdrop. So it's a beautiful example how you can completely vary structural style along the strike slip boundary in a space of 1,000 kilometers. And also the structural styles changes. So we have the distributed shear that is onshore. Then we have, let's say, rotational transtension inside of the Gulf. We have step over basing, as I mentioned, restraining bands, and okay, linkage over here in the north. So today I will focus on the field work that we did in the south, in Saudi Arabia, and also in Jordan. This is how it looks. There are a few examples. So, for example, here is my colleague Antoine Delonen standing next to an active fault in the area of Hagel, so somewhere here. Then, for example, this picture is coming from this zone when we have the Gulf, and then right next to it, we have a high mountain. So you can imagine that there is an important bounding fault that separates high basement of around 1,000 meter elevation to the depth of the Gulf of Aqaba to around 2,000 meters with sediments inside. And if you work in a strike slip tectonics, you know that looking at the elevation changes is very important. We work in a desert, so there's lots of great outcrops. For example, this is a nice fault zone that the fault planes already turn into clay. We also work on the southern area where we have the interaction with the normal faults, as you can see over here with the strike slip fault. So there is plenty of various structural styles in this area. But what we did at the first was to start with satellite images. So we looked at the major faults that you can map already from satellite images, and then we go to the field and we confirm them. We also look at Landsat images, so that helps us to see different lithologies. So, for example, this pink lithology over here is the Red Sea sediments. To be more precise, it's anhydrite, and with these kind of images, we can see offsets in different areas. So it's really helpful to trace faults in there. We also look at Aeromag data. So for example, this is a huge dike that is linked to the formation of the Red Sea. These dikes continues all the way to Yemen, and they are also on the other side of the Gulf. But whenever you approach the Gulf, you started to have offsets. So you started to see the influence of the continental break due to strike slip tectonics. What is also important to say is that, okay, we have these dikes going all the way to the south. They are straight as a knife, but while we go here, you don't really see them. And okay, so we can trace these faults with Aeromag data, but then in the field, we go there again and we see if we map it properly. And this is an oblique view. So this is the dike that I just showed. Here it's on the form and it's continuing down to the south or to the southeast. And with the field work that we did, we were able to map all these small fold that is basically distributed shear deformation. And when it comes to area closer to the Gulf of Aqaba, we started to see larger offset and the faults becoming bigger with the offset of several kilometers, while here it's just only a few hundreds of meters. So this is just to highlight the variation of the amount of offset. So again, this is these major faults that are close to the Gulf. We see that the offset is of several kilometers. For example, here, this is the biggest offset of 5 kilometers. As I showed with the dike offsets, we are about several hundred meters. And there are some areas where we were not able to trace any faults with satellite images or other data set. So we go to the field and we fly the drone over these areas. And for example, in this area, we were able to spot east-west oriented Precambrian dike. And as this deformation is much younger, it serves us as a really good marker to again see these distributed shear deformation. So basically, this is the all mapping that we did. Okay, we worked dominantly on Saudi and Jordanian side, but with the satellite images and previously published work, we were able to trace the map, trace the faults on the other side, so the Sinai side. And what you can see is that the deformation is fairly wide in the south on both sides, and then it narrows to the north. So what do I think would happen is that we had the distributed shear, the Sinai started to separate from Arabia. And then when it goes to the north, it narrowed to a more concentrated structure. What we also do is when we go to the field, these are the stops that I did during the first 2 years of the work. We collect fault zones where we were able to get carbonates. We send them to Andrew to Santa Barbara for dating with the uranium lead, and so far we have very good ages, so we could bound the deformation, the early stages of the deformations, which were around 23 million years, to youngest around 12 million years. And it fits really well what we also see in the seismic in the southern area. We have some seismic in this basin. And it also fits for the early stage of the deformation with what was published on Israeli side. Now, these distributed shear I wanted to compare with analog models, so I used already published example of Guido Shores. You can find this in the free publications that I listed here, but basically the model is fairly simple. You have two plates above the deposition, another layer of plexiglass, which is bounded by these wooden bars, and then as you move it, you have the distributed shears that looks like this, and these are the folds that you get on top. So you have distributed folds within a white zone. And here I compare Guido's results to what we see in the Gulf, on both sides of the Gulf. So if you look, for example, on these images, I also rotated the Gulf basically that the deformation is north-south, I mean up and down. And you can see that we have fairly much the same structural styles. We see that the faults are a little bit tilted towards the top left side. So I guess this model shows really nicely what kind of deformation we see on both sides of the Gulf. With the ages, we can confirm that it's the early stage of the deformation. And also when I was doing the mapping, there was no clear difference if these folds are dipping as a large flower structure nodes. They were really subvertical. Some of them, for example, in this area, were dipping to the east. So also the section and the model in the subsurface confirms what we see in the field. Now, the second model that I did, that was last year with Frank and Guido in Bern, that focused on the bigger picture, so the whole southern Dead Sea transform. As I mentioned, we have these opening towards the south along these three step-over basins, so Hula Basin, Sea of Galilee, and Dead Sea Basin. Then we have this transitional zone where you don't have much of the negative elevation change. And then again, from here, it continues south and it's open with different structural styles. So we have a bounding fold that are bounding the Gulf. And they are also stepping a little bit onshore over here. And inside you have these initial folds that are oppositely oriented to typical reader shears. So this is the model that we did. We have two plates with one kink. We move Arabian plate towards the north. Sinai is rotating, and this is the ending stage of the model. So the white zones shows you where we open the model, and if you compare these white zone to what really is open along the southern Dead Sea, it matches pretty well. And this is just top view of the model. Okay, so we see that the upper part is moving as we simulate Arabia, and then the Sinai is rotating. So let me just make it faster so you can see how the Sinai is rotating clockwise. And with this kind of setup, I basically have the transition zone where I don't have much of positive negative change. I close the transtension in the north and I enhance the transtension in the south. So that works pretty well to simulate what is happening along the southern Dead Sea. And this is an image when we were running the model in Bern, and this is the top view results. So the direct comparison between the two structures. Okay, the quick conclusion. So Dead Sea transform is a beautiful place. Everything is outcropping, different structural styles. In the field, we were able to look at the early stage of the deformation. This is now over. This distributed shear that we see offshore is not active. It was confirmed by seismic and by dating that we did. Then for the active part, what is happening inside the Gulf, we also have a nice model that explains how is it formed and how it works. So if there is any questions, I will be happy to answer, and I will finish with this nice picture looking from Saudi towards the Gulf and looking over Sinai on the other side.